All right, let's get right into it. Welcome to this explainer. If you're a focused learner gearing up for board exams, or honestly, if you just want to master the absolute highest yield facts about measles, you are in the exact right place. Today, we're essentially hacking the exam blueprint. We're skipping all the fluff and strictly breaking down the pathophysiology, the clinical presentations, and most importantly, the exact traps examiners are going to use to test your knowledge. 12 to 18. Lock that number in your head right now. That is the basic reproduction number, the R naught, of measles. To put that into perspective, the seasonal flu has an R naught of roughly 1 to 2. So, yeah, measles is literally the most contagious of all directly transmitted pathogens. It spreads primarily through respiratory droplets and small particle aerosols. And here's the crazy part. Those aerosols can remain suspended in the air for long periods, especially in enclosed spaces. A single infected person can spread it to up to 18 susceptible people. So we've got a really tight blueprint for this explainer to make sure we cover everything you need. We'll hit the virology basics, map out the clinical triad and that classic rash, break down the specific complications and their crucial timelines, go over the absolute rules for treatment and prevention, and finally, we'll tackle the immunity paradox traps. Starting off with the absolute foundational virology. Here's your first massive buzzword: antigenically monotypic. Measles is a single-stranded, negative-sense, non-segmented RNA virus from the Paramyxoviridae family. That's a mouthful, right? But here's the high-yield takeaway. Unlike influenza, which is, constantly drifting and shifting around with its different H and N subtypes, measles has only a single serotype worldwide. Because it is antigenically monotypic, vaccines that were developed decades ago from just one single strain, they still work. They remain highly effective across the globe today. Moving from the virus itself to what it actually looks like in a patient. You probably already know the clinical prodrome starts with the classic 3 Cs: cough, coryza, and conjunctivitis. But the ultimate clinical buzzword you need to scan for in any case vignette is Koplik spots. These are pathognomonic. And by that I mean, if you see them, boom, it's measles. They are these tiny bluish-white dots on a red base, typically found on the buccal mucosa right opposite the lower molars. But wait, here's the major exam trap. You have to know exactly when they appear. They show up 2 days before the rash even begins, and then they fade right as the rash makes its appearance. So, following those Koplik spots, the rash emerges. And this perfectly illustrates another high-yield term, cephalocaudal spread. The maculopapular rash doesn't just pop up randomly. It follows a super strict top-to-bottom order. It begins right behind the ears and at the hairline, spreads down to the face, then down to the trunk, where it actually often becomes confluent, and finally, it reaches out to the arms and legs. We call this a centrifugal distribution. Oh, and it fades in that exact same top-to-bottom order. Now this next part, this is where the examiners are really going to try to trip you up. Complications, and specifically their timelines. Timeline markers are essentially your cheat code for answering multiple choice questions correctly here. They'll give you a neurological complication, and the time since the initial infection is your biggest clue. So let's map it out. Giant cell pneumonitis happens acutely. Less than 2 weeks later, you might see post-measles encephalomyelitis. Months later, MBIG can occur, and then, remarkably, 5 to 15 years later, SSPE can develop. It's absolutely crucial to contrast these mechanisms. Let's look at post-measles encephalomyelitis. That happens within 2 weeks, and its mechanism is entirely autoimmune. Basically, it's an immune response targeting myelin basic protein, causing periventricular demyelination. There is literally no measles virus actually in the brain at this point. Contrast that with MIBE, which occurs months later only in immunocompromised patients, and SSPE, subacute sclerosing panencephalitis, which strikes 5 to 15 years later. Both MIBE and SSPE are driven by a persistent viral infection in the brain. SSPE is slowly progressive, universally fatal, and here's a key detail. It's most common if the child originally caught measles before they were 2 years old. Let's rapid fire through the broader complications. Because measles induces such severe immune suppression, secondary bacterial infections are incredibly common. But do not mix up these next 2 facts. Ready? Otitis media is the most common secondary bacterial complication overall in children. But bronchopneumonia, that is the most common cause of measles-related death. If a patient's fever drops and then suddenly returns, you need to suspect a bacterial superinfection immediately. Also, keep in mind that this intense immunosuppression can reactivate latent tuberculosis and causes a profound immune amnesia that lasts for over 2 years. Okay, so how do we handle it? Let's talk treatment and prevention rules. Spoiler alert, there is no specific antiviral treatment for measles. That means supportive care is your baseline. But the absolute star treatment that examiners will be hunting for in your answers is vitamin A. The World Health Organization recommends 200,000 international units per day for 2 consecutive days for children 12 months and older. Lower doses are used for infants under 12 months, of course, but replacing vitamin A is just paramount to reducing morbidity. When it comes to prevention, we've got active and passive rules to follow. The active MMR vaccine uses a live attenuated strain, specifically the Moreton or Schwartz strain. Now, because it is live, it is strictly contraindicated in patients with severe T-cell deficiency due to the risk of progressive infection. And just to touch on the historical context you often hear, the sources are very clear on this. Multiple studies have thoroughly disproved the retracted 1998 paper. The MMR vaccine does not cause autism. Lastly, for passive immunization, administering immunoglobulin within 72 hours of exposure can actually prevent the disease in vulnerable folks, like infants under 1 or pregnant women. Let's bring it all home with what I like to call the immunity paradox traps. So the crucial point here is understanding the divided roles of your immune system when it's fighting measles. You've got to contrast cellular immunity with humoral antibodies. Think of it like this. Cellular immunity, your T cells, is absolutely essential for clearing the acute measles virus and actually recovering from the illness. On the flip side, your humoral immunity, those are your antibodies produced by B cells. That's essential for protecting you against future reinfection. Let's look at a thought experiment that perfectly proves this paradox. Why is it that patients with agammaglobulinemia who lack B cells entirely and cannot make antibodies, why do they recover fully from a primary measles infection, while patients with severe T-cell deficiency face a massive risk of fatal giant cell pneumonitis? It's simple, really. B cells aren't needed to clear the acute virus. T cells are. Without T cells, the virus just replicates unchecked in the lungs, creating those giant multinucleated cells. Okay, let's run through a quick checklist of the most easily missed traps examiners love to use. First up, severely immunocompromised patients actually do not develop the classic measles rash. Wait, why? Because the rash itself is an immune-mediated response requiring cellular immunity. So no T cells, no rash, but unfortunately, a much higher fatality rate. Second, remember that post-measles encephalitis has no virus in the brain. It's an autoimmune reaction. Third, SSPE occurs 5 to 15 years later and is a persistent virus. And finally, measles requires strict airborne precautions in healthcare settings. We're talking a negative pressure room and an N95 respirator, no exceptions. I want to conclude this explainer with a pretty powerful quote directly from our sources. Measles erases immunologic memory to previously encountered antigens, increasing susceptibility to other infections for greater than 2 years. This is that immune amnesia we talked about. The virus actually goes in and depletes your pre-existing B-cell and T-cell memory. It really leaves you wondering, just how much unseen long-term destruction does this virus cause, long after that characteristic rash has completely faded away? Keep that in the back of your mind as you review your notes. Thanks for joining me today, and keep focusing on those high-yield connections.